Okay, good morning. Welcome to
KidMath number 59.
KidMath number 59. So after a little bit of a break for Thanksgiving, we're back and starting chapter 14 of our Art of Problem Solving Algebra book, and it's about graphing quadratics. And so we're going to be doing some stuff on Mathematica in this chapter, but we're going to do our movies on the board. So the first thing we talked about was just a simple parabola that we made, and this was the graph of y equals x squared. Okay? And how did we make this graph
Well,
the first time?
we made a chart of y and x, and we did x from -3 to 3.
Okay, yeah. We just made a little chart, plotted some points, connected them up, and we got our little parabola. Now, it turns out there's a bunch of different things we can do to this parabola that we talked about. And we're going to study most of these in this chapter. Okay? What are some things we can do to it? Describe them geometrically, and then we'll write them down.
Well, we can raise it up, like bring it to here.
Okay, very good. All right. So.
Or bring it down.
All right. So let's put that for number 1. Raise up / down. All right. I see it. Up / down. Okay. We can raise it up or down. So we have a nice graph, and this could be true for any graph we have, right?
Yeah.
Raise it up, raise it down. It's going to turn out that is actually not that hard to do in using math.
And you can also stretch it out or smush it together.
You could smush it together and make it like a super tall parabola, or you could stretch it out this way and make it kind of a really flat parabola.
Like a bowl.
Okay. All right. What do you want to call that?
Stretch and smush.
Okay.
I think it's
STRETCH.
How do you spell smush?
Smoosh. SMOOSH. Smoosh.
And then you can.
That's not right. Actually, I was just kidding.
You can.
That's okay. We'll use that for our verb. Smoosh.
You can slide it.
Okay. Slide it. What does that mean?
It means like you bring it left or right.
Okay. Awesome. Slide. Slide left or right. Okay. So you can imagine just picking up a graph and moving it over here or moving it over here. Or the same thing, by the way, would be keeping the graph in the same place and taking the axes and sliding them.
Mm-hmm.
Either way. Okay. And there was one other thing you mentioned that actually is pretty cool. By the way, 1, 2, and 3 are actually really easy to do mathematically. And you're going to study in this chapter these 3 things. But there is one other thing.
You can turn the entire graph.
You can turn the entire graph. Okay? So you can imagine having this whole thing on a piece of paper and just turning it so that the parabola is going over here. Right?
Or like this.
Yeah, or completely sideways or upside down. Now, turning it completely upside down
That's easy.
is actually pretty easy, or reflecting it across the axis is actually pretty easy. But turning it like 45 degrees sideways, the math for that is, believe it or not, the math for that's actually pretty hard. And something that you're not going to learn about, actually probably for a couple of years, believe it or not. But it's very easy to do. If you had a piece of paper, you can just turn it sideways, right? So it's actually, in terms of like things to do, it's not super hard, right? Just turning it sideways. But the math that describes that is actually pretty difficult. But you see it all the time. You see it all the time. Like, if you're ever watching, what's one of the like cartoon movies that they do with computers? What's one that we've seen?
The Simpsons.
The Simpsons maybe, although I was thinking more of something like Toy Story or something like that, where they have objects like, flying through the air or rotating. They're very, very interesting math behind that, but it's a little more difficult than these first 3. Anyway, that's what we're going to talk about. And good job, sweetie. Good job this morning.